Right, good morning, folks. A very warm and sunny welcome to you all. Summer is officially back, certainly if you're in the UK. In the UK today, we had a bit of a wobble there. Great to see the sun back out and once again talking about sustainable design on a Wednesday. This week around, we are back onto RIBA 2030 and particularly talking around how to improve your building design process against that framework as a nice thing to kind of latch onto. But there are things to pick up on here beyond RIBA 2030, which we'll talk about. And I'll mention that shortly. So the talk of this presentation over the next kind of 45, 50 minutes will be generally optimizing the building design process, trying to reduce risk, and we'll be basing that around the RIBA 2030 framework. All of you will have logged on via MESHWORK. MESHWORK is going from strength to strength. We're now pushing on for almost 400 members. So we've gained almost 400 members in 3 months. It's fantastic, and we're working on getting some great groups on there as well. Kat, our MESHWORK Guardian, is busy working on course material for the coming months, and we've got a whole load of fantastic speakers lined up. So there's a lot of work going on in the background for MESHWORK. Thank you for being part of it already, and great to have you on the webinar today. Do tell your friends. It's still free. We're going to keep it free for the foreseeable future. So as I say, feel free to invite people, become an ambassador for the site, and hopefully accelerate your learning about sustainable design in the built environment. By way of a quick bit of housekeeping, you guys will be used to this. No doubt you'll be sick of flipping Zoom meetings. Mic's on mute. Do use the chat box. I'm not going to answer questions kind of as we go through. I'll answer questions at the end. So if you do have questions, however trivial you may think they are, probably there's 5 other people thinking the same thing. So put your messages in the chat box. We're recording this webinar for the benefit of others. If you have to drop off, you can watch it afterwards. This will go up on YouTube on our Mesh Energy channel today, and do subscribe so that you keep up to date and get reminded about other videos that are going up there. We've got hundreds of videos up there now, and building a really good repository of material up there. So do sign up to that, and we'll be recording today's session. So a quick 30 seconds on who Mesh Energy is. We are an independent and holistic energy consultancy. We work very, very closely with a whole load of design partners, very frequently architects who are at the heart of low energy projects. And really our aim is to bring toolkit and a wide range of experience to the party, and really try and help people who are trying to do sustainable design, whether it's your first or your 50th design, trying to make that successful and as hassle-free as possible. It's getting pretty complicated, and with regulation changing in the near future, it's going to get even more complicated, and it will be a bit of a minefield. So we're here to help that and actively work with you and the other stakeholders on the project to deliver that with lots of smiles on faces, and hopefully a project you can be really, really proud of, and share and market the hell out of to win some more sustainable business as well. So that's Mesh Energy. Cover the UK. We're based down in the south. Really friendly team. Do reach out after this if you think we can help. So folks, we are going to cover the following areas today. So as I say, I'll try and speak for maybe 40-45 minutes, then we'll leave kind of 10 minutes for questions at the end. We're going to have a look at the RIBA stages again. Hopefully all of you are familiar with the RIBA stages. Whether you are or you aren't, we are going to remind you of those, and particularly with regards to sustainability, how sustainability impacts those various stages. We're going to be looking at various tools that are available to help you design sustainable buildings. And I think importantly, I'm going to talk to you about design risk, or increasing design risk, and the rewards of changing the way in which, or modifying the way in which you design buildings. This is kind of a fascinating thing, and some of this stuff may not be obvious to you, but I can promise it's all based on a lot of experience. So that'll be a handy little bit of the presentation. And then the kind of the meat at the end, we've got the sustainable and successful design process. So bringing all those things together, and really us giving you as many nuggets of information as possible to try and make your design process more rigorous, less risky, more successful, and more insightful as you move on, and I see you're trying to jump over higher and higher and higher sustainability bars, whether that's self-inflicted or whether that's been kind of forced upon you. And then we'll wrap up with some key takeaways. So without further ado, as I say, I've based this around the climate challenge. If the climate challenge is new to you, it's the background for the climate challenge is RIBA declared a climate emergency back in 2019. A lot of local councils and the UK in general has declared a climate emergency, and the UK is committed by 2050 to get to this point of kind of carbon neutrality, or zero carbon, loads of other words used. And the RIBA came up with this voluntary kind of 4-module framework to help design teams, and specifically architects, to try and navigate more holistic building design and give you targets to try and hit by the end of the decade to get you on that road to 2040, 2050, kind of net zero carbon. Some practices are really going in hard with this and really trying their best to reach targets for the end of the decade today, and others are just kind of dipping their toe into the water. But the framework is reasonably simple. It's made of 4 sections. We're looking at reducing operational energy, looking at reducing embodied carbon, looking at reducing potable water usage, and focusing also more on health and well-being, with a particular focus on overheating and ventilation. So those 4 areas, the percentage reductions that you can see on the slide are the reductions by the end of the decade. They're quite significant, given that we've been kind of kicking the can down the road for a while. This is quite a steep improvement that we need in our building designs in order to meet these targets. But given our practical experience, actually a really easy to understand framework. There's a bit more clarity coming out, as I say, in the coming weeks, not least around embodied carbon. Actually, embodied carbon is a difficult one for a lot of design teams, and it's certainly an area we've had to do a lot more thinking about. And work that Letty and the RIBA have been doing over the last kind of 6-9 months has meant that there's better alignment of the embodied carbon targets, which the Greater London Authority, the RIBA, Letty as an organisation, have agreed to. And the RIBA are going to re-release the climate challenge with updated embodied carbon targets in the next week or so, I understand. So look out for that, and we will be promoting that so you can very, very quickly find it. But a really easy to understand framework. And we're going to be talking around this as part of this presentation to kind of make it a bit more meaningful. So the RIBA stages, these should not be a mystery to you guys. There are essentially 8 stages, labeled 0 to 7. We've got strategic definition, preparation and briefing, concept design, spatial coordination, technical design, manufacturing and construction, handover, and in use, and kind of post-occupancy evaluation. So stages 0 to kind of 3 are your before and up to planning. Stage 4 is your kind of technical design phase and going out to tender, and then you've got construction in stage 5 and 6 for kind of commissioning, and then stage 7 is once the building is occupied. As I say, it shouldn't be anything particularly fancy there. What I do want to bring your attention to is the way in which sustainability gets layered on to those various stages. Apologies if some of this text is small. Hopefully, if you've got a big screen, you can see this a bit better. But we've got the stages across the top here. I mean, they've got a whole load of objectives and tasks, be that kind of environmental, social, economic kind of areas, which give a bit more depth to these various stages. And the areas that have been highlighted here, as I say, are based around kind of sustainability. And you can see this is quite heavily front-end loaded. So there's a lot of stuff to do up to kind of stages 3 and, particularly up to stage 3 and equally stage 4. And then as you get into construction, that diminishes. And that gives you an insight into the way in which sustainable projects need to kind of change and be thought about compared to traditional construction. But the reason I bring this up, and there's a lot of information in here, is my concern at the moment about quite considerable areas of this that I see overlooked on many projects. And so if these are all the things in these multicolored lovely boxes that you're supposed to do, the ones that I've circled here are very, very, very often overlooked or just completely ignored. Now that will change, and there are architects who don't ignore these and don't overlook them, but they're ones that need a lot more focus, not least because a lot of this involves a bit more analysis, involves some more money up front in projects. And so I wanted to just very, very simply highlight the areas that I think are particularly weak in here. And you know, we'll go on to talk about those. So the question is at the moment, how are projects spending their kind of time in these phases? And how are people traditionally kind of tackling design projects? And the answer is this: often there's very little done in those kind of early stages, stage 0, 1 and 2. There may be some kind of vague sustainability aspirations for pre-app, you know, your local councillor or not local councillor, but local council may have asked for, you know, 10% reduction, voluntary reduction in kind of carbon to show that, and you may slap a few kind of solar panels on the project, but there's not really a lot of thought that's kind of gone into it. There may be one kind of pre-commencement condition there. So you think about that, and you say to the planners when you go in for planning, yeah, you know, we'll stick some solar panels on, it'll be fine, and pretty light touch. What then often happens is it gets planning, and during the detailed design phase and prior to construction, there's a lot of onus put on the MEP engineer or the mechanical and electrical engineering team to kind of design the renewable systems. And often what happens is, if you're lucky, you'll find an MEP consultant that knows it and can write a proper specification. Other times they'll simply pick up the phone to installers and get the specification from the installer. The installer will give them loads of information. So they'll kind of essentially like subcontract out the design, either because they don't know about it or they're lazy. And as I say, there may be a bit in there where the installer is essentially designing the system that you've probably paid your mechanical and electrical engineer to do. So it's very much the kind of the tail wagging the dog. Not a lot happens through construction. You might do SAP calculations at the very end of the project, just to tick some boxes, and that is it. As you can see, not a lot of effort, but there is a disproportionate amount in the kind of the technical design phase for the MEP engineers to do. Not a lot joined up there. And what we're talking about is more joined up thinking and more effort involved at the front end to better cover off sustainable design and decrease risk, as you will see. So what we're suggesting here to have a think about is, in as early as stage 1, more clearly talk to the client about sustainability aspirations. I can promise you that more clients will have more sustainability aspirations now. They're more aware of it in the public domain, and more will happily talk about it. Don't be afraid of talking about it in those very early scoping meetings with the clients. Have a look at benchmarking aspirations against, you know, the design or the way that you would normally design a building. So if you're used to building out of typical materials, or you think you might use a palette of materials, or you think you might go for certain U values or wall thicknesses or whatever, you know, benchmark it against some of these frameworks you might be following. And if you're following, I don't know, RIBA 2025 or RIBA 2020 or RIBA 2030 or BREEAM or whatever it is, benchmark the design at that very early stage against those frameworks to see where you're at. Avoids any kind of early surprises and may allow you to adjust. And remember, this is all before planning and doesn't have to cost a small fortune to do. Once you get that feedback, you iterate and kind of optimize the design and start doing some initial kind of high level M&E design work. And then when you go in for planning, then you're far more confident with the design that you're putting forward to the planners. You can tell a better story to the planning department, particularly around the sustainability if you've done early stage SAP calculations and energy calculations. There's a more rich story to tell the planners there, and less surprises also should you be given the go-ahead. And actually, there's less work during the technical design phase to do. You've pushed some of that effort earlier on in the design process. You've got an energy strategy. There's not a huge amount of heavy lifting that has to be done. You've got to do your due diligence and design all the systems as you normally would do, but it's not as much effort, I say, because you've done some of that thinking earlier. So you can see some of these lumps are really well joining together and far more steady rather than being peaks and small blips. The installer may still refine the right system, but actually you're not having the installer dictate to the project what systems should go in there. You're actually thinking with the design team, and the MEP engineers doing a better job of designing a holistic system, then going out to tender and maybe discussing with the installer, tweaking that solution. And then as you go through the build project, continually monitor how it's going, check that project against any modeling that you've done. And then when you come to do your SAP calculations, it should be a walk in the park. There should be no surprises there. You know you're going to achieve what you thought you were going to achieve. You know why certain decisions have been made. You know the impact of construction decisions as they've been made because they've been discussed with the wider team. And then at the end, then you've got your post-occupancy evaluation. And this is light touch, a focus on light touch here. Just getting some simple feedback from the client and maybe looking at energy bills to then kind of compare that to how you thought the project were going to go. So as you can see, this is much more smoothed out. It's much more joined up, much more continuous through the project. Heavily simplified, but it gives you an idea of what I'm talking about here and the sentiment. The other thing to understand is you get into sustainable design, particularly if you focus on the RIBA 2030 framework, the elements like embodied carbon, operational energy, potable water, and the elements that include around kind of health and well-being are not all equal. Depending on what you're designing and you know, choosing principles of construction affects, say, embodied carbon and, you know, I don't know, the amount of glazing and the aspect of the building, the orientation of the building, the various facades that you're using and the look and the massing of the building also affect overheating and daylighting and all those kinds of things which come into health and well-being. So to avoid any confusion here, this icon is embodied carbon, this is health and well-being. So I'm saying look at these as early as possible in your concept design phase. And I've given an indication here, the longer you leave them, the more critical they become. And this gets worse as you hit more and more and more tricky targets. So RIBA 2020 might be quite easy, but RIBA 2030, you're going to have to push these things earlier and earlier and earlier on in the project to reduce the risk here. Operational energy, you can push a bit later, not too much later. That's obviously affected by, you know, whether you're putting a heat pump in, the insulation of the building, various other things, but nowhere near as critical. And we see particularly embodied carbon targets being missed because it's thought about too late in the design process. Potable water can be left later. There are some fundamentals, particularly as you get into RIBA 2030, where tight levels of potable water usage can actually affect the kind of baths and showers and things that you're putting in to the building. But generally speaking, it can be left later in the design process. So again, this is just to kind of highlight some of the issues here. And one final thing to bear in mind is, and you probably think about this when I mention it, but health and well-being, you can conquer health and well-being in very, very passive means, passive ventilation, sensible building design, looking at your glazing carefully, using geometry of the building, overhangs and stuff to minimize overheating, to minimize the requirement for cooling, and really have a fantastic environment in the building through good design. Or you can leave it late and be lazy and throw technology at the problem. You can throw air conditioning systems at an overheating building or a building that hasn't been properly designed. And that's fine, and it will do the job. I say fine, it will do the job, but it costs money. It needs maintenance. It might add tens of thousands of pounds, particularly if you're after subtle, invisible units. So you can conquer health and well-being to a degree by spending money on it. But the smart way of doing it is looking at it as early as possible and looking at some fundamentals of the building design to do it as passively and cheaply as possible. So some observations. At the moment, generally speaking, there's not enough sustainable aspirations kind of questioning going on in existing projects. Energy aspirations and sustainability targets are not being quantified. So it's being left as kind of being fluffy. Architects are, bringing that to kind of the party too late. Maybe because of lack of understanding, maybe because they think there's other more important things to do on the project beforehand. And as a result, the sustainability strategy for the development in those early stages is not properly being explored. And as I say, as I will show you, that leads to increased risk. But also there's a lack of investment in early stage design analysis. We see as architects and design teams are becoming more educated in sustainable design, they understand the benefits of doing things earlier. They're able to have a more frank and meaningful discussion with the client at an earlier stage about low level of investment to do this kind of benchmarking in this early stage analysis. Very, very infrequently are we talking about tens of thousands of pounds. It's often hundreds or £1,000 to do some of this work. It's not mega money, and compared to the risk, it's a bit of a no-brainer. But until you've gone through that process and felt the pain where you haven't done it early, it's difficult to describe. And as I've mentioned there, so the results are impossible to benchmark the designs if you haven't got a framework to benchmark them against. Costs end up rising because of this kind of fragmented and piecemeal approach to the project. You're not doing proper kind of due diligence and analysis on it at the right level. And you miss a load of opportunities. This is all about missing opportunities. This is not about adding cost to a project. This is about saving a project money, reducing risk, making your life easier, and creating something better and more beautiful and more functional for your client, whoever that client may be, whether it's a homeowner, whether it's a hospital, whether it's a community group, whatever. So the toolkit, what tools are available to design more sustainably? Well, for operational energy, there are some pretty basic kind of British standard like calculators that you can come up with. We use some of these calculators internally for some kind of primitive work that we do for static heat loads on buildings. There's the CIBSE TM54 assessment, which is a kind of a methodology for working out operational energy in more kind of commercial buildings, although it can be tweaked for domestic buildings. Again, freely available. And you can work through with pen and paper. You can work through in Excel if you're good at that kind of thing. These are free tools. They're widely available. Nothing fancy about them. Or you can go, as you get into more detail here, you can look at dynamic energy modeling, building physics modeling, and bespoke, calculators. Which again, all of those things we use within Mesh Energy, depending on the level of detail that you're after. So some of those things are free, some of those things are paid for, and you need professional software. Embodied carbon, there are a number, and two, particularly ours and Field and Clegg Bradley Studios, Excel embodied carbon calculators. Those are free, and again will remain so for the foreseeable future. You've got plugins for Revit. If any of you use Revit, you've got HBERT, which is a free tool. And there are also ones like One-Click LCA, Sphera, SEMA Pro, which are professional tools, thousands of pounds a year for a license that will give you the highest level of detail. And as I'll show you, you can move from some of these free tools to more complex tools, which cost more money and cost more for professional advice to use. But these are some of the things that are available to you to combat some of these areas. Health and well-being, particularly focusing here on overheating, ventilation and daylighting. Although there is formaldehyde, and those kind of things mentioned in the health and well-being module, we are talking about fundamentally looking at overheating and ventilation and daylighting as the main contributors to the module and the main thing that needs improving. And very, very quickly here, because of the complexities of building physics and thermal analysis and air movement, you're very quickly into dynamic thermal modeling. We use IESVE, but there's also TAS, Design Builder. Some people use HEVA-Comp, although that's a bit too primitive for some of this stuff, really. It'll do ventilation, but it won't do dynamic thermal modeling. And then you've got daylighting modeling, which, you know, a lot of these packages do, particularly IESVE. So some of these packages will do the whole shooting match. Some will only do certain elements. And really very quickly, you've got to speak to professionals about using this or get some serious training internally to use these in any kind of meaningful form. Potable water usage is actually probably the most simple. There are free calculators available. There are BREEAM calculators. There's Part G domestic calculator, which again there are ones online. There are Excel calculators. Again, we use various ones internally to do. But potable water usage is a pretty simple one, particularly compared to overheating and ventilation and daylighting. So that's just a really quick kind of snapshot. And I can see Kate, actually, I said I wouldn't mention the chat, but Kate's just put up about Saphira, which is available in SketchUp as well, which can be used for some of these things. What I would also mention, this is something that I've brought up in a previous presentation, and this kind of links on to more kind of better, more robust design going into the future and based around kind of building integration or building information modeling, or BIM, is this thought about having a centralized model. And the power of having some of this software available is that it can give you multiple answers to multiple modules at the same time. Now, you can use a water calculator to work out what your potable water usage is, but when you get into operational energy, overheating, ventilation, embodied carbon, a lot of these things are intrinsically linked to U values, air movement, building volume, you know, weather files, all these kinds of things. And so speaking personally, Mesh Energy uses IES and one-click LCA very, very closely. And that allows you to build, rather than modeling these things independently, modeling it in one go and giving you answers to your embodied carbon questions, your operational energy questions, your well-being questions, and kind of all in one go. And that is hugely, hugely powerful. We're getting quickly to a point where to get accurate information about some of these sustainability areas, you need to start using software. You need to start using it in a smart way that works with the team, is quick and is efficient and works with your design process. There are also kind of proprietary software and calculators that can be used for embodied carbon, like, as I say, these free calculators as a standalone thing, but the real power comes from these kind of centralized models. So this just goes to show on a typical project how we may actually be able to give you answers to these modules, or you may be able to use with your current team and consultants to get those answers without doing these things individually, independently, and it becoming quite laborious. So just a final thing on the calculators and software. We all love free, nothing better than free. The problem is with free is that it's often basic information that you're getting, particularly in the embodied carbon calculators, potable water calculators. And you get to a point in some cases very quickly around overheating and ventilation stuff where you need to start moving to these professional tools. And it will vary depending on your level of confidence, the money in the project, the sustainability targets and level of detail that you need when you transition. But it's often in stage 2 and stage 3. Some people will wing it until planning to then get into the weeds, which is fine for, say, RIBA 2030, RIBA 2020 or RIBA 25. But for RIBA 2030, really, you need to start dabbling with more professional tools, even in the concept design stage, to make sure that you are as close as you hope you need to be, and that it's eminently possible to make those kind of last tweaks as you move through stages 3 and into stage 4 once you've got permission for it. Again, we've seen people who making gross assumptions about how great their designs are, have done no analysis whatsoever, and they get a short, sharp shock when they are a country mile off and they've gone far too far through the project. So this will vary from project, this will vary based on your experience, it will vary based on your level of risk, and it will vary based on the amount of money you've got behind your project. But it's worth becoming familiar with this and through project working out where this blended approach makes sense to move from free to paid for you individually, or for your team, or for your practice. So design risk and reward. Why is sustainable project risk rising? I can guarantee you it is. Don't for a moment think that sustainability is a silver bullet, and just because you're designing a sustainable building, all is going to be well. All is not going to be well. Sustainability, like with anything beautiful, it's all in the design. Beautiful and simple things take some solid design and some solid analysis and some solid thinking about. They don't just happen. And there is more care and attention that needs to go into sustainable projects to make them as great as they should be for the end user, and ultimately for the design team to get them there. Generally, buildings are becoming more complicated, so we're trying to keep things simple, but we're trying to be more complicated at the same time, which is a kind of bit paradoxical. But we love our technology, but we're trying to keep things simple. There are more variables now, and there are more targets that we're putting in the way, particularly with sustainability targets. That bar is getting higher and higher and higher. And as those targets get higher, the tolerance for error diminishes very, very rapidly. There's been many rules of thumb, and building regulations have been lax for a long time around building performance. And that is changing fast. And over the next few years, by the middle of the decade, when we get to future home standard and you're trying to reduce carbon emissions in buildings, new buildings, by 70 or 80%, that is a real challenge, and needs to be a properly designed system well before you get to approaching the planners about designing it, because it's not the kind of thing that you can cobble together just in the technical design phase. Sustainable technology is also costly. So again, for those who think, thinking less holistically and think just like throwing renewable solar panels and heat pumps and stuff at a project, mechanical ventilation, heat recovery systems, it's expensive. It's not a smart thing to do. So you need to figure out how you approach the fabric first element, air tightness of the building, then look at the renewable technology, our mesh energy hierarchy. I haven't got it up here, but throw your mind back to that about, the best way to spend your money and your time. And if you ignore those things or miss those things, the project risk rises, and in some cases is very, very risky indeed. But one of the last things here, which you may not have thought about, is how much clients care about sustainability. That has changed massively over the last 18 months, is not going away anytime soon. And it's one thing, making a bit of a kind of a technical boo-boo on a project. But if a client comes to you and their brief is they want something very, very sustainable, and you go through the effort of setting targets and this is their dream project, and you miss that by a country mile because the process isn't rigorous enough, that's going to sting more than spending another kind of 10 grand to solve a problem, I don't know, because you got a bit of the glazing wrong or something else. Clients care about this kind of stuff, and it's becoming very, very emotive, and that in itself is a risk, just massively missing client expectation that was set at the beginning. So project risk, this is perceived risk. I've kept this simple, and this is just a simple way of showing you guys what I'm talking about here. So perceived risk, we'd like to think that kind of sustainable projects are in the green zone. Yeah, there's more to learn. If we read enough books, we'll be fine, and we talk to enough people, we'll be fine. Keep it in the green zone. There's a lot of risk around the kind of technical design phase, but if we find the right consultants, happy days. Then when we're building it, all good. Wobbles a bit, happy days, we stay in the green zone. This is actually, for most people, if they carry on, or if you carry on the way that you're going with your projects, this is what is actually happening. We've talked about, you know, the worst risks are the ones that you don't see coming and the ones that you don't find out until the very end of the project. And so you quickly move into the kind of through the amber and into the red zone. In some cases, you can solve this by spending money, but not everybody wants to throw money at solving a problem. Why should they? Why should a client throw money at solving a problem that the design team has created? And the solution to this is, and I'll come back to kind of this BIM methodology and having this early stage analysis, light touch to start with, a good team, but having this kind of centralized model for the project. Actually, with better feedback during the design process with the right team members, you can minimize risk to an absolute minimum, far lower than you're at the moment. And you do that by getting feedback. And this is what sustainable design is about, good feedback. Forget post-occupancy evaluation. I think, you know, not forget it, but you know, we talk about getting feedback from the client in the post-occupancy evaluation stage. I'm talking about getting feedback at stage 2, stage 3, stage 4, stage 5, not leaving it to the end or not doing it at all. And by doing that, you keep the risk to an absolute minimum. But also there are massive rewards. The client gets better insight, the design team gets better insight. You know, there's valuable feedback for the design team, and we're talking about you know, not being precious about information here. I've been very open about being collaborative and the benefits that sharing design information has for that wider team. You know, sharing information between the structural guys, the sustainability guys, the architect, the client. You know, as long as you're sharing it in a constructive and the right way, it can be hugely beneficial and insightful. You get the difficult questions kind of thrashed out at an early phase rather than leaving grey things rumbling along to latter stages in the project. And feedback and learning, we've got to get used to the fact that we are on a very steep learning curve. We shouldn't be embarrassed about making mistakes. We shouldn't be embarrassed about learning. We shouldn't be embarrassed about asking why, because that is going to be the difference between success and failure in this area through this coming decade. And those who put their head in the sand and fail to learn will find themselves pretty irrelevant and out of a job very quickly. There's a lot happening and there's nothing that's going to stop it. But also improve client satisfaction. You know, the client knows you're in control. They think you're in control. They're getting regular updates. You know you're in control. You can sleep easier at night. So reduce risk for you. And in most cases, you can achieve high levels of sustainability than you ever thought possible, just with a bit of analytical effort on the project. But feedback is absolutely critical to most of these rewards. So the successful sustainable design process, really this is a kind of a summary of what we've been talking about here. I actually took this snapshot from the RIBA plan of works, and it's a great starting point. This is what we're used to, a very linear design process. The client speaks to the architect speaks to the structural guys do their bit, and then the MEP engineers get involved. Then the builder gets involved, then the builders build it, and you get my idea here. So it's a chain. You know, projects, I know projects are moving away from this, but think about most projects as a very linear thing. Everybody's in their silo, just kind of handing the project on from one to the other. A lot of opportunities missed. This is what we need to go to, this kind of hub and spoke design. And having something at the core of the design, whether it's a model, whether it's a design team, whether it's both, that are valuable and offer that continuity through the design process. From the earliest stages, even maybe just light touch at those very early stages. And the people, as I said before, you know, moving from this kind of linear approach to more group thinking, not being afraid of sharing information, being open to collaborative, you know, design of evaluation and kind of morphing and opening up those opportunities as a result. This is the way forward for projects. And where we've seen very successful projects, this is what has happened. The key stakeholders, the key consultants have got together early, and the client has bought into the benefits of that, and the design team leads, not least the architects, have bought into that benefit as well. And setting sustainability goals is critical. So you guys will have heard a similar sentiment to this. You need to know, if you want to get somewhere, you need to know where you're going, and you need to know what success looks like. I've talked about goals before in previous webinars. A project cannot be successful if you don't know what success looks like. And if hitting RIBA 2030 for a certain build budget is what success looks like, spot on, because you know that can mean something to the project, that can mean something to the design team, and that gives you a way forward. But then once you know that, rather than taking this kind of shotgun, blindfolded approach to kind of figuring it out as you go along, intelligently push doors, benchmark the design, find out what is great about the design, find out what is crap about the design, and work on improving those weaker elements to make the whole project stronger. And you will only be able to do that by getting feedback, doing analysis, to be able to move the project on. In any project, that will be the smartest way to do. Use intelligence and the tools available to you. So, as I've said, the key here is, through all of these design stages, is better understand client aspirations, agree and set realistic and ideally progressive goals. Come out of your comfort zone. Don't stay comfortable. You're not going to get anywhere if you stay comfortable. Involve key team members, put building physics or some kind of intelligent modeling at the center of the design as early as possible, and review your kind of finished project against those expectations. And just as a kind of a helper here, again, you can look at this presentation after the event. The key question here is, in these phases, when should you be doing something, who should be doing it, and what should you be doing? So I've just got the individual phases here, which I'm going to go through. And there's a quick mnemonic here, which I've got called Understand, which covers off the 8 different phases and gives you an indication of what I believe is something you really need to be focusing on in these individual phases. So we've got uncovering the client aspiration in stage 0, define those sustainability goals in stage 1, energy benchmark the design, refine, iterate, and optimize in stage 3. Remember, this is before planning in stage 3. Stage 4, get a holistic strategy together, detail during construction, sort out commissioning and handover in stage 6, and then discuss and learn from feedback in stage 7. So if you understand these stages and understand the benefits that taking a holistic approach to building design has, that mnemonic should help you going forward. And so as we go through the individual stages, I'll just rattle through these over the next couple of minutes, and then we'll open it up for questions. In stage 0, we're talking about the architect and the client here. Nothing too heavy. Look at the sustainable aspirations. Uncover the client's why. If you don't know what I mean by that, I've done various presentations on kind of goal setting. Our Right First Time presentation covers that off. Understand the real emotive reasons behind why a client finds sustainable design inspiring and what that means for them. In stage 1, in the kind of preparation and briefing stage, again, still the architect and the client here, set those targets and set some realistic sustainable goals. In stage 2, start thinking about bringing the energy consultant in here, get a concept together, play with the concept using these free tools, have a look at the operational energy, maybe embodied carbon. You've got your framework, so you've got a pretty good idea of what you should be targeting. You can benchmark the concept using kind of light touch software at that stage to kind of give you a kind of more robust answer than your free tools at very, very little cost, and understand the strengths and the weaknesses of the design. In stage 3, you may involve the structural engineer at this point as well, just to kind of make sure if your design is a bit more progressive structurally, just to make sure everything's okay. But again, you get into this kind of refined design, optimize and kind of iterate phase and solidify your energy strategy as a result for the project. So you know what the building can do, you know what energy you need, and you know how you're going to heat the occupants, provide hot water, do all these other kind of fancy sustainable things that you want to do on the project, on the client wants to do. And then during detailed design, you know, you're really just putting the finishing touches on material specifications, system specifications. You've got your full MEP detail to flesh out, and looking at confirming again you're going to meet your compliance targets after that detailed design phase. And into construction, you can look at getting kind of live feedback during construction. And if there are changes on site, which invariably happens, you can find out how that affects the goals that you're trying to achieve. Sometimes there may be a small thing you want to change, and other times there may be a bit of a showstopper. But if you know one way or the other what effect that's going to have, then you can make progress and take the appropriate action there and then. And as you get into kind of handing over as part of kind of commissioning and commissioning the system, you've got a kind of confident indication of kind of running costs, because you've modeled the project, particularly if it's a new one. And you can help the client understand the systems, or the energy consultant, and you can help you understand the holistic systems in the building. And then we get into post-occupancy evaluation. You can review the energy bills. And more importantly, as a design team, you can have a look at that performance gap analysis once you actually know how the building's performing and how it's been modeled, and then use that knowledge for your next project. So the key takeaways: uncover those sustainability aspirations in the first client meeting, understand yourself and then educate the client on sustainable design goals, invest in specialist advice from key stakeholders as early as possible, use centralized building modeling to kind of streamline the design process and make it as insightful for you and the client as possible, and de-risk it. Look at tapering kind of free tools to more professional tools through stages 2 and 3, and spend more time in stages 3 and 4 to really design and optimize and iterate your project to give you the highest level of confidence. That is it, folks. I know we've got a number of questions up here. Let me just have a quick whiz through there. I know, and it was very distracting. Who put that up there? Rob Wheaton. Apparently they've already come up with version 2 of RIBA 2021. I'm embarrassed that I couldn't tell you that, because all my channels said that it hadn't come out. So thank you very much, Rob, for chucking up that link. So there's a link in the chat about the new RIBA 2021 version. We'll be getting that out there. In fact, it even came out last week. So thanks for sharing that, and that should be more insightful for where the kind of the structure's up to. Yeah, Flavio said it's sad those plugins are only thinking of Revit, whilst there's a huge pool of architects using other software. Agree, Flavio. I agree. Obviously, Revit's used by a lot of the big practices, and you know things will change. But yeah, it is sad. I do agree. Syed says, apart from IES, are there any other software that does the TM52 and TM59 results? I believe, and I'd have to ask some of our other colleagues, I believe that, you know, any thermal modeling, dynamic building physics, thermal modeling software will be able to do kind of TM52 and TM59 results. I know within IES, there are various bespoke scripts that are kind of used to produce those specific results. But I kind of hands up, not using the software personally on a day-to-day basis. I couldn't tell you, but I'm sure there are. I know we've got Richard and some other guys on the call that be able to answer that question for you. But any of the decent building physics packages should be able to do that. Those are pretty standard European standards there for thermal modeling. Kate rightly said, and this is a really good shout from Kate, the Good Homes Alliance have an overheating tool, which is really, really easy to use. So if you're trying to get an early stage indication of overheating, you can use that. In fact, and Kate doesn't know this, but we are coming out with a RIBA 2030-esque sustainability calculator in the next kind of couple of months, which that will be a free tool. So at the moment, we've got our embodied carbon tool, and we will be coming out with a free tool, which in a single spreadsheet on multiple tabs, you'll be able to look at embodied carbon, potable water usage. It uses that Good Homes Alliance overheating tool, And also you can have a look at operational energy usage in a single free spreadsheet in those early kind of stage 1, stage 2 phases. So we have actually used that tool. I can personally say it is fantastic. So good shout, Kate, on the overheating one from the Good Homes Alliance. Rob, how does PHPP compare to IES in terms of modeling results? What is PHPP better at versus what is IES better at? Oh God, that's a question. Again, not being a kind of super user of PHPP, my initial thoughts on PHPP, Rob, would be around, I mean, PHPP is very much focused obviously around passive house. It delves into mega detail about thermal bridging and kind of operational energy usage. IES is, and PHPP is Excel based, whereas IES is a building physics modeling package. So you're actually essentially kind of CFD to away. So computational kind of fluid dynamics-esque. It's very much a kind of a three-dimensional tool. You can look at overheating and ventilation. So PHPP is great for passive house, but it is an Excel tool only, whereas IES is actually a three-dimensional building physics modeling package. So they are not the same thing by a long stretch. But PHPP for passive house minutiae is definitely the best tool, whereas IES is a more generic, or highly professional, but more generic building physics modeling package. And Kate's answered actually Syed's question. There's also Design Builder, which uses Energy Plus dynamic modeling. So that's another one that will give you TM52 and TM59 results. Oliver's asking, following on from Rob's question, would you consider using PHPP at an early stage for benchmarking operational energy? Yeah, I would do. I think, you know, there's more than enough detail, I believe, in PHPP to do that, Oliver. So yeah, you know, there's a ton of effort and detail that's got into that. You know, whether you can kind of keep it simple enough for those earlier stages, I don't know, but yeah, there's no reason why you can't use that for operational energy. Especially with various plugins available to speed up area input. Yeah, I think you can use it at those earlier stages. Including using the passive house trust tool within PHPP for checking overheating. I don't know enough about that actually, Oliver. That is a good question. I'm going to say maybe to that, but I would point you in the direction of that Good Homes Alliance tool that Kate was talking about. She's put a link up for. It's absolutely brilliant. You answer like 10 simple questions for stuff that would mitigate overheating and stuff that could increase overheating. Super duper quick and simple. So if you don't know the PHPP software, a really good generic, but actually highly insightful tool, that Good Home Alliance one. Okay, it's actually answered at length Oliver's question, so I'll leave it to that. Loads of other responses. Glenn, unfortunately, I don't know anything about Insight whatsoever, so can't answer that question. If somebody else knows something about Insight, be good to get a response to Glyn there. Flavio's asking, I'm curious, what kind of wind turbines are being developed for residential usage? Oh, right, okay. That a bit off tangent, but I'm happy to answer that, Flavio. Wind turbines for built up areas or domestic projects are pretty much dead in the water. There's so much turbulence in built up environments that close to the ground that they are pretty useless. That there was a lot of chatter and hype about it, you know, kind of 10, 15 years ago, but it's died a death. Really meaningful ones, you get up to kind of 5 meter kind of tower height before you get anything kind of meaningful, and you've got to be in really kind of open ground to do that. So not a lot going on in small wind turbine territory at the moment. I don't think there's any other questions, folks. A huge thank you. What I would say, I'm going to big up Richard Bowman. I'm going to be hosting that one. So next week, Richard Bowman is going to be talking to us about the London 2021, London plan, but also the London 2021 update. So the London plan was recently updated to capture some more kind of meaningful, progressive sustainability targets and building design targets. And we're going to be sharing with you those highlights next week. So delighted again to have you guys with us. As I say, this recording will go up on YouTube today. Carry on the discussion on MESHWORK, and we look forward to seeing you next week. Cheers, guys. Take care. Thanks a lot. Bye.